Wait, our table's the first ones in the entire class.
This never happened.
Bonus points.
Bonus point.
Wait, you want me to get you some?
No, give me all of them. Not just.
No, I'll only get you 2.
Just get her 3 of the same ones.
That'd be funny.
Why would that be funny? Like, why would that be something that's a good joke?
That's stupid stuff.
I've like never been more stressed out in my entire life as I am today. My car broke down this morning.
Stop good.
No, I know. I was just like, I should not be this stressed out. Yeah. I hate that that's a joke now because like. Me and Miriam were talking yesterday about how you guys are both busy. No, I know. She told me that.
You did?
Oh, that was so funny.
So funny.
I feel bad.
So I didn't get an answer for this thing at once. I spent 15 minutes working on it and I couldn't figure out how to do it.
Did they have the same second one? Was that just the rotating in the bottom?
Yeah.
And you got the first one? The parking one? Bro, that was
I didn't really get either of them.
Part 3 is
Wait, what did you do?
like, part 3 is impossible. The first one, all I did was see the equation.
No, and they didn't give us an option to put the squiggly line.
Oh, I just did it.
Yeah, that's what I was.
All I did was show you where
Exactly.
Exactly. That's what I did.
Really? What about the green?
It seems like, I tried to do it, but all my 30 minutes.
I probably spent like 40 minutes. It's like literally like
That's our key practice on the.
I think I left it on for my own.
That's really bad.
Get like half credit for you.
It's like, there's
Yeah,
6
I was like,
questions.
sometimes.
And but
My
you
dad
only
wants to get to a gas station.
so you don't actually.
You're good.
Well, it's just you're gonna have to do all 6.
You're just gonna have to do all
6 in a row.
Yeah, I can do that. I can work with that.
Oh my god.
I had so much makeup because usually I was sick for the whole week. Then I had one week I was trying to make stuff, and then last week I was really bad. No, I missed Monday.
So much, we're just getting so much work right there. That's why.
Because I'm doing AV with like 4 different classes.
I took part of my exam this morning, and then right after I had the class, and I took the other part of it. So I've written 3 essays this morning, and I'm already so exhausted. Yeah.
I do, because I missed the
I was just gonna pick you up.
I had to write both of them in class from yesterday. And then the assignment yesterday, I gotta do that at home tonight, so.
We, on Monday, we did mock MCQ, and then this morning during the practice, we did the argumentative and everything. And then the next class, I'm doing the synthesis.
We did our MCQ on Thursday. How long is it?
All right, guys, the bell's not going to go off. I think they're going to keep the bells off for the rest of today. But there was a couple things I asked you to turn in for homework. Those are both under bell work. So if you forgot to do that, please come and give them to me so that you can still get full points on those. We are going to try to do one practice FRQ, look at a couple more mock exam multiple choice questions, and then do one review topic that I know you need to see again that should be pretty easy for you once I review you. on the circuit. So that's the plan for today. Homework, I've got you turning in a couple other things. 127 from last class, 128, which is what we will be doing the first FRQ here in just a minute. And just turning those two in, you should have them done. Or you should have both of them done in about 20 minutes from now. And then the last part of the mock exam. So good news is this is a B week, so I won't see you again until Monday, so that gives you more time. But you need to have all 6 FRQs finished. So if you did the first 2, 30 minutes like I asked, then you should have 4 more for 60 minutes. And you don't need to try to score them or anything outside of class. Just doing the 4 in 60 minutes is already a big ask. So please do that. I will give you some class time to score them and talk about cutoff scores and what your score would be and all that kind of stuff. So. Okay, any more homeworks that were not in Google Classroom already? Okay, before I set a timer on this number 128, this was from 2017 FRQ2. I think last class we might have done 2017 FRQ5, so it was from the same year. But this one has a pretty decent average. I think it was at least 4.01. Okay, so barely 4. But this was one of the famous questions from that year. It was it's one that's about bananas. So a couple classes ago, I had a meme where it had part of this banana one. But based on the average, you can see that it's not on the harder side. It's on the probably slightly better side. So that doesn't mean that that's where you're at right now, but that's where they were at the end of 2017. Okay, anything, this is a calculator allowed FRQ, so that either means you need a calculator or you're allowed a calculator. Some calculator stuff, just like the multiple choice, not every calculator multiple choice question needs a calculator. Just like every part of a calculator FRQ doesn't need a calculator, but there's a good chance that you'll need it for at least 1 or 2 parts. So, anything you need to ask or clarify before I set us a 15-minute timer and let us get started? Okay. Again, as we do these, I'm about to start it, but as we do these, please start trying to put in the best effort that you can. If you've really been trying to pick up a point or 2 here or there, you want to see that start to help and come together before the day of the AP exam. So just keep that in mind. All right, go ahead and start, please. Time's up. That was 15 minutes. So when we get a little bit closer to the AP exam, I will tell you the types of FRQs that tend to show up more often than others, but this is certainly one of those. This is referred to as a rate in / rate out type of question. And I don't have the FRQ in front of me, so you'll have to bear with me, but let's start looking at the scoring here. So I think they wanted you to determine how, you have to tell me yes or no. How many bananas were removed during the first 2 hours? That was question 1. So to know how much has changed in the first 2 hours, that would be integration. Integration keeps up with how something changes. Oh yeah, if you need to borrow a different colored pencil or pen, please come and get it. So they gave 1 point for the answer, 20.051 pounds of bananas, and they gave 1 point for writing down the integral, which would be this, or in place of f of t, you could put, I don't know which one was, I gotta get a copy of the FRQ, so nobody can come up. There were 2 different functions to take from. So the one that was about taking it away. The one that was called f. That's why they're saying f there. So again, you can just say f of t, or you can write out all of what f of t equals, but I don't know why you would do that. If you write it down wrong, you get that point wrong. So integrating f from 0 to 2 would tell you how many bananas got removed during those 2 hours. Everybody okay with that part? Now again, these are a lot of the same-ish type of stuff. So unfortunately, if you struggled with that part, you're probably going to struggle with the rest of it. But part B wants to know what's the derivative of f at 7. Now, you could do this by hand, but I hope that you didn't. You have a calculator. Your calculator can do derivatives at a specific point. But your calculator must be in radian mode. So the fact that f has a trig function in it, if your calculator was in degree mode, you got a totally different answer. So 1 point for the value, either negative 8.120 or negative 8.119, depending on if you rounded or truncated. And then 1 point for the meaning. So exactly at 7-hour mark, the rate that bananas are being removed, or you could say added if you do negative, or removed if you do positive. That's what you're finding. You're figuring out how fast they're being removed at the 7-hour mark. The rate of change at that instant. Okay, part C. Another 2 points, divided up very evenly. Part C wants to know, is there more bananas being added or taken away at t equals 5? So this isn't even really any calculus to this, because if you want to know exactly how much is being removed at time 5, you would plug 5 into f. If you want to know how much is being added at time 5, you would put 5 in for g. So if you take how much you're adding at that instant, take away how much you're removing at that instant, you would get this number, which is less than 0. So if in your work you showed that you considered f of 5 and g of 5, you get a point, even if it's wrong. If you considered f of 5 and g of 5, you get to count that. Now if you did that and you didn't write it down, you got to learn to write it down. Anything that's going in your calculator needs to go on your paper. And then since that was a negative number, you should be able to say that it was decreasing, and decreasing because it was negative. Because g of 5 minus f of 5 is negative. Yeah.
Wait, so if I got it wrong, but I mentioned G of 5 and F of 5, that
You would still get the
counts?
first point, yeah.
Okay.
You considered those two things, yeah.
I didn't subtract f of 5 from g of 5. I just said that f of 5 is greater than g of 5.
That's the same thing. It's equivalent to this. You just added that over.
Okay.
Yeah. Okay, and then finally, I feel like we had one like this last time. How many pounds of bananas are on the display table at time t equals 8? So, if you forgot one thing here, it's probably the 50. Integration tells you how it's changing. How many bananas you've added over time, how many bananas you removed over time. But if you want to know how many bananas you have to know what you started with. So that was right there in the first sentence, and then you didn't have to use it to the last question. Sometimes you need to reread the question more. So to get the final answer right, you had to factor in the 50. They had 23.347 pounds of bananas. And the way you should have done that is how many bananas you started with plus how much you added over time. Why are they only doing, for adding, why are they only doing from time 3 to 8?
Because the equation starts at 3.
Right, so anything they put on there is something that you probably need to use. If you look at g of t all the way to the right, he didn't exist until 3 to 12, so that's why you can't do 0 to 8. He didn't exist the first 3 hours. They didn't put out bananas the first 3 hours. Take away how many bananas you took away over the 8 hours, and that's where the answer came from. But for this first point, 2 integrals, I would assume they would give you 1 point for this one and 1 point for this one. I can't promise that. It might be 2 if you get both and none if you don't get both, but I think they would probably give you 1 for each. That's how I would grade it. So if you remembered about how integration helps you keep up with stuff as it changes, your average score should probably be fairly close to 4. And if you didn't, then it'll probably be a lot easier next time. But try to find a point or two, grade it out of 9. Do y'all have any scoring questions? Yeah.
On B, I said the rate is, I said it's the rate at which bananas are being removed, in pounds per hour, but I didn't say specifically after 7 hours. I just said at f prime, I just said f prime 7.
I don't think that would count
Okay.
because you didn't explain what the 7 meant in context of the question.
That's what I thought.
So, all things considered, the fact that this was one that students complained about a lot, it had a pretty decent average. So, if you struggled with this one, again, we will practice more rate in, rate outs, and I'll give you a list of about 10 more that you could practice outside of class. But rate in, rate out, this type of problem where there's a function for how fast something increases, a function for how fast it decreases, this is almost a guaranteed to be one of your 6 type of FRQs. So, since FRQs are typically what y'all worry the most about, feeling very confident about this type of FRQ going into your AP exam will definitely give you some breathing room. Any other comments, questions, suggestions? Yeah, Jack.
For C, I
Yes.
didn't say that the total was less than 0. I said that the amount taken away is greater than the amount being added. Does that count still as a point?
Did you say at time t equals 5 or just in general?
Yeah, I said like f of 5 is less than g of 5.
Yeah, that's the same thing. See, look, here, if I just do the algebra to this, you could add this over, and that's what you're saying.
Yeah.
That's the same thing, it's equivalent. Okay, so how do y'all feel about that one? Does that seem easier than normal or about the same? A little easier? Anybody get all 9 points?
I would be able for that one.
That's fine. That's what you got to learn. You got to learn like, oh yeah, I need that part when they want justification. Okay, we're going to look at just 2 more mock exam questions today, so I would prefer if you pull those up on your Chromebook or at least on your phone. We're going to look at question 21 and 24. Again, these are 2 questions that were highly missed that I think doesn't take a lot of time to talk about how to fix. So I do need to pause the class recording for just a second. A couple questions on the circuit are actually already finished for you. So notice at the top of the page, these are the 2. Now, of course, I didn't make this circuit, but they put a lot of good notes here for you. Here's the basic, definition of a derivative. That's the one I was referring to start off that mock exam question. You got a lot of information here. When it's in this format, this is the function with the plus h next to x, and this is the function with the number plugged in. Sometimes they plug in a number, sometimes they just leave x. This is the alternate form. It's just a different version of slope formula. You're subtracting y's over subtracting x's. So those are the 2 that you will want to memorize before your AP exam. But again, the first 2 are already finished for you with these notes. This is the alternate form of the derivative. You just think about which one of those 2 it matches up to the most. In the alternate form, this is the function. And all of this is a long way to say take the derivative. And since this is the alternate form, this is what you want to take the derivative at. Take the derivative at 3, so that's where they're getting 30. They typed up the same thing. But there's a hint about what the function is. The whole thing saying take the derivative, and then there's hints about what value to plug into the derivative. Okay, and then I'm guessing they did 2 because this is the other form. This is not the alternate version. This is the main one. So when I look at this, again, it's typed up, same thing here. But when I look at this, this is f of x plus h, all of this. So that tells me f of x must be 5 to the x squared. This whole thing is a definition of a derivative, so I need to take the derivative of that, which would be, I need a 5 to the x squared times the natural log of 5 times the chain rule. And then over here, this is f of a, so this is the function with a number plugged in. But they didn't plug in a number here. Not everything is going to be numeric. So this is what happens when you just plug in an x into that. That's their answer. Now, if you're confused about this derivative, again, this is chain rule, and this is the derivative of an exponential function. The derivative of e to the x is e to the x, e to the x times the natural log of e. If you do something else, like 5 to the x, it's going to be 5 to the x times the natural log of 5. You got to do it times the base. So same idea, but you just don't use this one as much. Okay, so that's really what you got to get out of it. You need to try to memorize those top 2, the limit definition and the alternate version. Depending on which one it looks like the most, it gives you a hint about what the function is and what, if any, number you need to plug into the derivative. So try to think about what the function is, take the derivative, and then maybe plug in a number. And then that's how you should move forward. So we can do one more, but I'd like you to try number 3 on your own. Notice they even numbered box 3 for you. So try this one over the next few moments, and then I'll tell you what I did, and then I'll let you work at your pace. Okay, I'm going to cut you off here. That's really all the time you should need once you get the hang of these. Most of these should be pretty quick once you get the hang of it. This looks more like this version, the limit definition, because as h approaches 0, the denominator's h. That's how I know that. So this must be f of x plus h, which is my hint that f of x must be x to the fourth. This whole thing is a roundabout way of saying derivative, so I could take its derivative. And then over here, this is the function, and sometimes they plug in a number, and sometimes they don't. So if this had said 16 here instead of x to the fourth, well, if I think the function is x to the fourth, and this was saying 16, that means that they would be plugging 2 into the derivative. They didn't do that this time, so they just want you to plug x into the derivative. And if you plug x into the derivative, it's going to be in terms of x, not in terms of a number. So, again, you're really just doing derivative, but you're trying to extract what's the function in that mess, what form does it match up with, and do I need to plug a number into the derivative or not? So let me give you a few minutes head start, and then I will come around and help out. But again, I know this one has more questions, but I think I did all of these in now they're a little easier to me because I thought about them more, but I did all of these in 20 minutes this morning. So. And don't forget that you can still try L'Hopital's rule on these two. Question number 1. I know they did question 1 for you, and they told you how they went about it. But notice in question 1, if you did L'Hopital's rule, it would take you about the same amount of time. Actually, it would take you way less time. I just did it. So feel free to do L'Hopital's rule if you think it's easier. Okay, and with our modified schedule, you guys have 30 minutes, so that's probably going to be about right for this assignment once you get going. Yep. What do you think the function
F of A is, it's just that, they just put.
is? And what's the derivative of that?
So that A is not times that A.
You know, different.
Try that again. Your derivative.
Oh, wait, Rose, who's that wrote this one as a negative or something? Thing going nuts.
Well, it's going to become negative after you do the derivative. But
Yeah.
you kind of jumped the gun there. Yeah, find the derivative of that, and then you're done. All right, what do you think?
Why would it just be
I was just saying.
Oh, you're just talking about how to answer it, I guess.
So you need to think about
One of them
the
cosine
first.
pi squared, so it's like.
This is your
Yeah, so
x
it's
plus h squared.
Cosine pi is
So your
negative
function
one.
is going to be so your function is x to the fifth, and they're plugging in 2.
One.
Because this is supposed to be your x plus h squared. But plus h isn't gonna be part of the real function, you're adding that to this. So the original function was x to the fifth. So you need to start with that, say the function's x to the fifth.
Well, can you just solve
All of that's asking you to do the derivative.
I think it's.
And
Well, I'm
then
just saying
this
that
one, they
you
want
just
to
do
know
like
the
a double
derivative
limit
of
on
two.
these, right?
You're plugging in 2 for x.
No.
And you see if you plug in 2 to x to the fifth, it would be
Yeah,
there's
I guess
that's why
technically
it's
you
there.
could do
That's what I'm saying, dude.
So maybe
It's like that question on that question.
x squared plus
Third, plug it in the zero.
which will get you started.
You guys aren't done yet? You're not done yet? Okay, I agree, number 8 is 75.
Cube root of
It might be good for you to look back at that mock exam question too, when you finish the circuit. It should seem a lot easier of an approach after that. After you have more practice. No, this one's right.
So cube root of x.
So 8 is equal to x, right?
What's your shit too? Well, cube root of 8 is.
You have to.
Well, you have to take the derivative first. So it's 1 over
So x 3 is cube root of 8. It's 1 over 8.
That's number 9. I'm just gonna wait for your answer.
we got 8 to the 1/3.
Wait, no, you're right, sorry.
We got it down, it's 1 over 3. Over
No.
8 to
Yeah,
the
yeah,
1
'cause
negative
It's 8 to the negative 3.
to the 1/3.
If you do.
You're right.
Yeah, if you bring down.
1 over 3.
Well, it would be 8 to the negative 2/3. It would be 8 to the negative 2/3. Or, well, it would be
Oh, yeah.
8 to
Subtract it
2/3.
I have that as 5.
Cube, I'll just put cube.
I don't have that as 4.
Yeah, that's the same
Go
thing.
back.
So cube root of 2 squared, 4 6, 1 over 12.
Okay, now, if they wanted you to find the derivative at 0, they would plug in 0 here, and this would be 0, and say that. So they didn't plug in number in. Your answer to this question should just be, 4x to the third. They didn't plug in. Sometimes they're gonna plug in a number, sometimes they just want you to keep it. Well, yeah, or it just won't be there because, like, let's say the function's x to the fourth. If this was a 16 here, that would tell you they want you to find the derivative of 2 because x is 2. For that to be a 16, if the function's really x to the fourth, they would have a 16 there. So, that one was just a number. So your number 4 should be, yeah.
Is
So wait.
it x squared minus?
Yeah, it's x squared minus
3x?
3x, yeah. Yeah, I think that's just, and if x is negative 4, or negative 4 squared, 16. And this is 12.
Which is
Plus
12.
12. Yeah, so
Yeah.
yeah.
That's right, okay.
Not much.
3,
That one is the hardest one.
plug in negative 4.
Yeah. Well, it's probably just one and bump them all up.
Oh, you guys
Where's your number?
Yeah, I guess that's.
I have that as number 20.
Okay. And then x is negative 4, so you plug that in. So then you get negative 11.
That's 19.
That's okay.
So you're 18, so you're gonna have all those.
Natural log x.
Okay, I have that as 18. But it's correct. Oh, so all of these are correct. Because you have the wrong number.
Yeah, it's 3.
I have those 17. That looks great. Well, you just need one.
We're more than halfway through now, right? There's 24. So So, what do you think for?
That function yours.
Yeah, why is it? I mean, I guess that was
That's
wrong.
the function of the
Way wrong. Yeah.
Yeah, it is. Everything plus 8 to fill. Yeah, so the function is x to the fifth, and they want you to find the derivative. That makes sense over here. This is supposed to be the function,
Yeah.
remember what it is. That's why I said.
We can obviously just substitute for it.
Well, yeah, but we don't allow like the one good idea is we have four review. Yeah, we have 0.
You can sit by me every day if you want to.
That sounds awesome.
I'll leave it open for you.
Samuel told me that I have to sit here or else he's gonna get me.
Well, you can sit over there with us too.
Oh, Samuel. We just like leave Spencer.
What did you get, like negative 10? Just like switch the signs or something?
Yeah,
Because I know negative 1 is an answer.
that's why they're plugging in here.
I don't know.
H to 0 is part of the definition. If it's that form, it's telling you what derivative you want, but on this form, it's always going to say it's equal to 0.
Well, no, we did that, then we have to put the sign
I will try to show you maybe.
Well, we could just do negative G if that doesn't work either. Well, but then it doesn't actually do anything.
Oh, what is it? You got that then? Oh, wait. Yep. What about the two?
Yeah.
I mean, what if we just, well, alright, think about it, right? If we just put the signs of all of it, the whole thing turns negative. And G of 3 plus H minus
So
G
it would be like that?
G of 3 derivative of that is 10, and if the whole thing's negative, which means that's in negative, so we didn't have that. So I'm just gonna write it down and then, whenever he comes back, that's when
We can ask.
write it. Let's see if this works.
It is.
I mean, it's gonna get us somewhere. Yeah, these are good.
Each of the 2 exponents.
Well, I see.
That's 2,
Well, what's the?
negative 2.
Keep going.
How do you do those again?
It's about 2x, yeah.
What's secant
Negative 2
squared?
e to the 2x times. Wait, or yeah, which is.
One. Tangent is inverse sine.
So would it be composite? Because you know, like, you have to do times natural log. But these negatives are times the negative.
What did you get on the?
Or negative natural log, you would use negative log. So then,
Yeah, I would make it.
where y'all get the
What did you get?
Is that even in the
Oh wait, the negative name there.
Yeah.
Yeah.
So it's, so it was 2x plus 1.
Yeah.
That's it, right?
Oh, okay.
It's not large.
That's probably
The sin x.
Why can't we do secant?
Well, this is just, this is. Oh, H, yeah, H is a long ways. So, this is, see, to me, it looks like
So,
H wrong.
why?
It looks like H is replaced with X, and X is replaced with 1. Yeah, they switched it, and then they made X 1.
Yeah, like what's the?
Because X approaching 0. Instead of H approaching 0.
Oh,
So
yeah.
they're trying to trick us. So it's like 2X to
I was
the,
kind of wondering.
2X to the power.
I just think about
Like two.
2e to the power X.
2e to the power of x. And
2 to the
then,
power of X. Because X is 1 here. Because X plus 1.
so is it just 2e?
Yeah. Well, it would just be 2 or 2 0. So how did y'all get? Oh, but if you do 1.
I think it's just 2.
2 yeah.
2e is an answer.
Yeah, it should be 2 because I don't have to replace it.
Yes, I think it's just 2e. Wait, maybe it's not.
Okay, so they replaced the H with X.
Yeah.
And then the X.
Honestly, on that one, I struggled a little bit.
Like,
So I
H and
just
X
did
are
both Charles
switched.
rules.
So then the H, which is now
Because the derivative
X,
of the
which
top and
became
bottom are so
H
easy that it's easier than trying to figure out.
Because X plus 1. You know?
Don't forget, if
So
one
the
seems
other one
harder,
is
you can
2e
do
to the
the
power.
so instead.
Yeah. So
You can do either one.
and then 2e to the 1. So which would make it 2e to the x, the base equation, which would take the derivative and plug in. So it's just like, yeah. Number 16, 2e.
When they plug 8,
Okay, so we, that other one was right.
We didn't get checked anymore on that, or?
I think that's 7.
I don't know, maybe it's
what?
that's just how you know, if it's backwards, just make negative.
Wait, what's the derivative?
And to check to make sure you guys are still on the right track.
It's negative 17. It's negative sine x.
Yeah.
So okay, 1 over,
You got-
cosine is 1 over cosine. So cosine,
Okay, that's not my
Negative
17, but your answer is right.
The derivative.
That's my number 16, but you don't.
1 over 2 negative 1 over cosine 2.
I would rewrite it, x to the -1.
Oh, is it just-
Bring the power
sorry.
down, lower the power down. It would be negative 1
Okay,
over
so
x.
it's just negative cosecant squared.
And don't fall into the trap of doing natural law. You're thinking integration and do natural law.
Alright, go.
7.
Negative cosecant cotangent. What's your Oh, the chain rule. Negative 2x. Negative 2. It would be x squared. Which one? X squared. No, because you didn't get the derivative.
No, you don't take the derivative on the inside.
Well, you can change the
Wait, well, you just put that on the outside, but it's
Yeah, there's a negative 2x.
Is the function.
Oh, I
plug
see.
it into it. So, that's your function. So take the derivative, so we get 5x to the 4th. And then, see how they lost the x is got 2. So they want to know the derivative after 2 to the 4th. And then this over here is the function with 2 plugged into it, that's why that's the 32.
2. Isn't it just 2 cosine x times negative sine? So negative 2 cosine x. So it would be 2
I said the function was x squared minus 3x.
negative 2 cosine x.
And then negative 6 and negative 4.
T versus negative secant tangent.
Wait, there's something. There's something about it.
Oh, yeah.
Oh, actually, never mind. I got confused for a sec. My bad.
So T is the X, and they just like switch the signs. Because it's T approaching that 6, so X approaching A, so T would have to So T would be negative.
Do we need to do this?
Why is T would be there?
Would it be 6? Because T said it has to be.
Just be. It would just be negative 1. Because if T is X, half of X, it's a derivative. And then it's supposed to be negative because I switched the signs. You see that? Because I switched the signs, so we're going to do negative 1.
I'm wondering,
Because you take the derivative of T.
I'm just using, okay, here's what I'm doing. I'm wondering
And what's substitute negative?
Like, X is just negative T.
What number?
Yeah, that's what I'm saying. Yeah. So that's why it's 6 plus T. It's negative T minus 6. So negative 1.
Yeah,
But negative 1 is the answer.
it is an answer. That may be right.
so it would be,
I think it. Yeah, I think it is. It's on the same.
1 to 3 answers.
You don't take notes?
1 over
so 1 over 3x is just 3x with negative 1.
My goal is to make it real like No, I know that's the thing. I'm gonna say your
I know.
Well, yeah, yours is equivalent, right?
It's like, well, that's, you have to remember, they're not wanting you to plug in pi over 4 into this.
I don't think this
It's
was.
that if you plug pi over 4 into
Because
this.
negative 1 over 3x squared is the last one.
Oh, okay.
This is
So
not.
they're wanting you to think about what angle has a tangent,
That's,
at.
yeah, it's right. It's just, this is 23.
or what is the tangent at pi over 4?
So then this is something else.
And then that will go.
1 over 3, 1 over 3,
And 1/2.
That is 19. Y'all got number 13? 13, I thought was the hardest one.
We struggled on it for a while.
Yeah, you see how these are like switch?
That's what we did.
There, yeah, that's all you gotta do. But that's a, they wouldn't do that to you on any test. At least not
Yeah, we were
quick.
confused for a while, but we eventually kind of like figured it
Okay,
out.
19, honestly, I couldn't figure out which one was which, but I didn't try very long because I just did L'Hopital's rule.
Can we just do that?
If direct substitution would give you 0 over 0, you can always do L'Hopital's rule.
Okay, yeah.
And since
So 1 over
L'Hopital's,
3 T squared.
and then you still need to plug in.
Negative 6.
So it's negative 1.
L'Hopital's rule is just way easier there. There's no need to try to figure out what form they set it up with.
We assumed that we started off with negative T, like we tried to do utilities.
Yeah.
We put the sign.
Well, it would have to be this one, because this one's always h approaches 0. So,
Yeah.
but that's still weird.
But that's why we figured we did it wrong, because when you have negative T, we thought it's a negative 1, and then negative 1 into negative 1.
Yeah, so we.
It's not.
This one they have, they replaced it.
Yes.
Sorry.
So square root of
I just
x.
keep myself from zero. Colored all. That's not zero. Wait, I'll touch Spencer's too. So that we can
Two square root of 3 is like.
I'll see what you're touching this right now because I'm touching it and then also. Right here.
One square.
There's 1 over square root of 3, and then there's 1 over 2.
Let's
Oh, I did say physics, so I know.
Oh, hold on.
Yeah, wait, you got it. Wait, do it so.
So.
Oh, this is a good angle. Do it.
So 3 is x.
Okay, you guys still have 8 minutes, so try to get a couple more done, please. But like we've been doing, you do not have to finish this circuit for homework, only because I'm giving you other homework to finish the mock exam. So finish up another question or two, find a good stopping place, and make sure you have it in your binder as 129. We'll work on it another day.
Because 2x over x, yeah. So 2x can't be. Wait, no, you can't.
No, it can't be. That was like. So 2x over x. The function, okay, the function is square root.